Hi everyone, my name is Max Leamy and today I'll be presenting the charge tapes experiment. As an introduction, in this lab we applied charges to pieces of tape that we called U-tapes by attaching the U-tape to another piece of tape used as a surface and ripping the U-tape off of the surface tape. We then observed the interaction of the U-tape with charged objects to determine the magnitude and sign of the charge on the U-tapes. The result of the experiment of levitating one U-tape with another was the top U-tape had a net force of 0 at a separation distance of 0.026 meters, and we were able to find the charge of the U-tapes by observing that the electrical force of the top U-tape and the gravitational force on the top U-tape had equal magnitudes to keep it motionless. For the physics concepts from the experiment, the electric field equation, electric force equation, gravitational force equation, equation to calculate the number of atoms on the surface of the tape, equation to calculate the deficient electrons, and definition of equilibrium of forces were used. The electric field equation and electric force equation were used to calculate the repulsive force on the levitated U-tape and the charge of the U-tapes. The gravitational force equation was used to calculate the attractive force on the U-tape towards the Earth. For the experiment, I created charged U-tapes by ripping the U-tapes off another piece of tape surface. I then observed the attraction of the tape to my hand and the negatively charged pen, and repulsion of the U-tape with another U-tape. Finally, I levitated one U-tape using another to overcome the force of gravity on tape B with the repulsive electric force from tape A. The initial charge of the tapes before ripping them off of the tape surface is neutral. The charge of the U-tape after ripping off was observed to be positive. The system of the experiment of levitating tape B is tape B, tape A, and the Earth, and the surroundings is nothing. From the experiment, I observed and documented the mass of the tape shown on screen and calculated the force of gravity on the top U-tape using the equation from the physics concept slide. I then observed the electric repulsive force from the bottom U-tape must be equal in magnitude and opposite in direction the gravitational force on the top U-tape. I calculated the charge on the U-tapes by setting the electric force equal to kq1q2 over magnitude of r squared times r hat to find the charge of the U-tapes QB, 1.204 times 10 to the negative 8th coulombs. I divided this charge by the charge of an electron to find the number of deficient electrons. I then found the surface area of the tape and surface area of an atom by assuming an atom is essentially flat like a square. The total number of atoms is surface area of the tape divided by the surface area of an atom. I finally found the ratio of deficient electrons to atoms. For my coding demonstration, I first define my constants K, the charge of an electron, the force of gravity, the tape length, tape area, tape mass, separation distance, and area of an atom. I then wrote code to calculate the gravitational force on the top U-tape and the electric force on the top U-tape using the same methods from the previous slide. After that, I found the charge of the U-tapes, number of deficient electrons, and number of atoms using the equations from the previous slide and from the physics concepts. Finally, I created spheres to represent the tapes as point masses and added the gravitational force and electric force to the top U-tape as arrows pointing from the center of the U-tape. For the discussion, you can observe that the bottom and top U-tape are both positively charged, so the white arrow represents the repulsive electric force of the bottom U-tape on the top U-tape, and there is an electron efficiency because of the positively charged tapes. The red arrow of the model represents the gravitational force acting on the top U-tape. As expected, the net force on the top U-tape is 0, and therefore it remains at rest, or in the experiment's case, levitated. I did not account for air resistance or attraction of the U-tapes to my hand in the experiment. The diagram of point charges works well to visualize what is happening to the top U-tape. Some sources of error may come from miscalculating the separation distance of the two tapes, or miscalculating the mass, length, and width of the tape, and rounding error due to calculations. Possible error is also due to not holding the tapes properly when completing the experiment, or neglecting the other charges that are present. For the first what-if question, if the electrons and protons changed their charge signs, the electric field for the tapes would point towards the tape instead of away from them. The U-tapes would be repelled by my hand and the negatively charged pen instead of being attracted. Although the charges swapped, the U-tapes would still repel each other at the same distance away and give the same results for the coded experiment and floating tape experiment. For the second what-if question, because the charge is centered on the outside of the tapes, coming into contact with the tape with any part of my body or any other surface risks moving the surface electrons from the tape onto your body or other objects. Thank you so much.